Coding Sahai, I am Reshma. So friends, have you done the 6 programs we discussed in the last video? There were 14 programs using if condition in Python. So out of that we did 6 programs. So in this video we are going to discuss some more programs, and the remaining programs we are going to discuss in the next video. So there are 3 parts for if condition programs. Part 1 already uploaded, and part 2 is this one, and part 3 Saturday 6 p.m. you can expect. If you haven't watched the flow of control, if constructs and the if programs part 1, then the links I have mentioned in the description box, you can check it. So let's start. So before we start, if you are new to my channel, please do subscribe to my channel and share the videos. So let's begin. Write a program to find the largest of 3 numbers. So here we need to input 3 numbers and we have to find out which is the largest number. So let's see the logic first. After that, let's write the program. So we need to find the largest of 3 numbers. So for that I am using 3 variables A, B and C. Okay, so to compare 2 values, we can check like this, like A greater than B. So if A is greater than B, we can say A is largest. So in this case, we have 3 values. So how can we compare it? First, we need to check A with B. And if it is satisfying, we need to check A with C. That means A greater than B. If it is true, what we have to do? Again, we have to check A greater than C. If it is true, then what we can say? A is largest. But when we check A greater than C, if it is false, then what we can say? We can say C is largest. Suppose when we are checking A greater than B, that time you are getting a false return value. That means A greater than B is false. That means B is largest in A and B. So that B should be checked again with C, B greater than C. So it is satisfying. Then we can say B is largest, isn't it? Same way, when we check B greater than C, it is not satisfying. B greater than C is false. Then we can say C is largest, isn't it? Then we have one more else case, that is we are all the opposite condition. A greater than B, A greater than C we checked, and A greater than B and B greater than C we checked. So if both these conditions are not satisfying, then we can say C is largest. Okay, so this is the logic for finding the largest of 3 numbers. Let's write the program, and after that I will explain with the numbers. So here I am giving the comment, largest of 3 numbers. 3 values you have to input. A equal to int input, enter the first value. Then second, B equal to int input, enter the second value. Then C equal to int input, enter the third value. So now we have to check if A greater than B. If this is satisfying, then what we have to check again? If A greater than C. So if both the things are correct, then we can print A is largest. Else A is not greater than C, then we can print C is largest. If A greater than B is not satisfying, then we can give elif B greater than C. We can print B is largest. Otherwise, both the cases are not satisfying. A greater than B and B greater than C, both are not satisfying. Then we have an else condition, print C is largest. So this is our program to find the largest of 3 numbers. So first let's save it and run the program, and after that I'll explain with the numbers. Okay, so it's asking enter the first value. So I'm giving 25, then I'm giving 21, then I'm giving 12. So here it is printing 25 is largest. Let's give the second value as largest and then check it again. So here I'm going to give 12, then I'm giving 35, then I'm giving 22. Okay, so 35 is largest. So that is also working. Third time. That is, we need to give C as largest. So I'm giving 1, 2, then 45. So 45 is largest. So all the three conditions are working properly. So let's give these values in the program and let's crack the code. So in the first case, I have given A equal to 25, B equal to 21 and C is equal to 12. Okay. So according to the logic, we have to check A greater than B. That is 25 greater than 21. Is it satisfying? Yes, it is true. So it is checking if A greater than C. That is A is 25. So 25 greater than 12. Is it satisfying? Yes, it is true. So it prints A is largest. That is 25 is largest. So our first condition is working properly. So in the second case, I have given A equal to 12, B is equal to 35 and C equal to 22. So here it is checking whether 12 greater than 35. That is our first condition. So this is false. It is not satisfying. It doesn't go inside this if condition. This part won't be executed. It directly goes to this elif part. So in the elif part, it is checking whether B greater than C. What is B? B is 35. 35 greater than 22. Yes, it is satisfying. So it prints this line, B is largest. That is 35 is largest. So this was our second condition. Then in the third case, I have given A equal to 1, B equal to 2 and C is equal to 35. Okay, so here first it is checking whether 1 greater than 2. Is it satisfying? No. So it goes to elif part, that is B greater than C. That means 2 greater than 35. Is it satisfying? No, that is also not satisfying. So it goes directly to the else part, whether C is greater than all other values. So here it prints 35 is largest. So these are the three conditions we checked here. We can check with one more value. I'll show you. Here I am giving A equal to 100, B equal to 50 and C equal to 200. So in this case, first it checks A greater than B, that is 100 greater than 50. Is it satisfying? Yes, this is satisfying. Then it comes to this line whether A greater than C, 100 greater than 200. Is it satisfying? No, this is not satisfying. So it goes to the else part. So what is the else part here? C is largest. That means 200 is largest. So this is our program to find the largest of three numbers in one way. So this program, we can do it in another way. So we are going to do this program with relational operators and logical operators. Logical operators you studied and or not. So using and, how can we rewrite this program? Let's see that. See here I have given if A greater than B, then we are checking if A greater than C. See here we can combine these two lines as if A greater than B and A greater than C. This one we can delete. So here this else part is not required. So here it is checking whether A greater than B and A greater than C. Both conditions should be satisfied. Then we can say A is largest. Otherwise it is checking whether B greater than C. Then print B is largest, otherwise C is largest. Let's save the program and run it again. So it's asking first value I am giving as 12, then the second value as 10, third value as 9. Okay, let's see the output. 12 is largest. So it's working properly. Run the program. So first value I am giving 3, second value as 5 and third value as 1. So 5 is largest. Then again first value 1, then second value 2 and third value I am giving 3. 3 is largest, and then I am giving first value 10, second value 5 and third value 20. 20 is largest. So all the cases are working properly. So using logical operators, we can combine the line like this. So here A greater than B and A greater than C. Both conditions should be satisfied. Then only this print A is largest will be executed. So this is our program, largest of three numbers using logical operators. Okay, so let's do the next program. So our next program is write a program to check whether the entered year is leap year or not. That is, you need to input a year, then we have to check whether it is leap year or not. So you know what is leap year, right? Okay, we say if the year is divisible by 4, then it is a leap year. Is it completely correct? No. So let's see the logic of leap year. So the first condition, if the year is divisible by 4 and then it is not divisible by 100. That is, for leap year there are some conditions other than divisible by 4. If the year is divisible by 4, then it should not be divisible by 100. Then only we can say it is a leap year. Same way we have, if the year is divisible by 100, then it must be divisible by 400 also. Let's see an example. See here 1980. 1980 is a leap year. That means 1980 can be divisible by 4. That is, you can check it. Okay, so you are getting 495. That means here remainder is 0. So 1980 is divisible by 4, but it should not be divisible by 100. 1980 by 100, if you do, there should be a remainder. You may get the remainder as 8. So it is not completely divisible by 100. So this condition is satisfying. So we can say year 1980 is a leap year. Suppose, see, the years like 1800, then 1900. These years are divisible by 100 and it is also divisible by 4 also. That is, if you take an example, 1800, then if you check with 100, that is divisibility, you are checking with 100, then it is completely divisible, right? Same way we can check with 4 also. So if you are dividing 1800 by 4, you will get 450. That means it is completely divisible by 4. Here the year is divisible by 4 as well as 100. So according to the first condition, if the year is divisible by 4 and then it is not divisible by 100, it should not be divisible by 100. So it should not be a leap year. But there is one more condition, that is, you have to check whether it is divisible by 400 also. That means 1800, if it is divisible by 4 and if it is divisible by 100, then it should be divisible by 400 also. So let's check. 1800 divided by 400. This is correct. 18 divided by 4, it is not completely divisible. You will get the remainder as 2. That is 4 4s are 16. Then 2 more is there to get 18. So you will get the remainder as 2. So we can say 1800 is not a leap year. See here I am taking the year as 2000. 2000 is divisible by 4. First we have to check with 4 only. So here you will get the answer as 500. That means remainder is 0. If year is divisible by 4, then it should not be divisible by 100. See, obviously 2000 can be divisible by 100. 2000 is divisible by 100. So here it is not divisible by 100 is not satisfying. So we have to go to this line. That is, if the year is divisible by 100, then it must be divisible by 400 also. That is 2000 divided by 400. So here it gives, okay, it is satisfying, right? So all these three conditions are satisfying. That is, if the year is divisible by 4 and if the year is divisible by 100, then it must be divisible by 400. That is, if the year is divisible by 4, then it should not be divisible by 100. If the year is divisible by 4 and 100, then it must be divisible by 400 also. So that is our leap year. So let's write the program. Giving the comment leap year. So we need to input year equal to input enter the year. Now we have to check whether it is divisible by 4 and not divisible by 100. So we have to write if year modulo 4 equal to 0 and year modulo 100 not equal to 0. If it is satisfying, then we can say print year is leap year. Otherwise, year modulo 100 equal to 0 and year modulo 400 equal to 0, then we can say print year is leap year. Else, otherwise, print year is not a leap year. Let's save the program and run it. So it's asking enter the year. So I'm giving 2024. Okay, it's printing 2024 is a leap year. Let's check with other years. Here I'm giving a century year like 1900. So 1900 is not a leap year. So now I'm giving a century year again like 2000. 2000 is leap year. Let's crack the code with these values. So first I have entered year as 2024. That is 2024 modulo 4. Whether 2024 is divisible by 4. Yes, you know, that is if you do 2024 divided by 4. 5 2s are 20. Then here. Then in 2 it does not go. So 0 here. Then 24. 6 4s are 24. So you are getting a remainder 0. So this is satisfying. And one more condition we have given here. Year should not be divisible by 100. That is 2024 divided by 100. This you know it is not divisible. So this is satisfying. So we can say year 2024 is a leap year. Let's check with the second value. Second I have given year as 1900. 1900 divided by 4, that means okay 30, 7 4s are 28, then 20, then 5. Okay, 1900 modulo 4 is satisfying. Then we have to check 1900 should not be divisible by 100. That is the first case. But you know 1900 divided by 100 is completely divisible. So this first option will not be executed. So here it is checking whether year modulo 100 equal to 0 and year modulo 400 equal to 0. See here year modulo 100 it is satisfying. Then we need to check whether 1900 divided by 400. So here 0 0 we are cutting this one. 19 divided by 4. See you know 19 divided by 4 it is not completely divisible. So we can say year modulo 4 is not satisfying in this case. So it goes to the next line, that is our else. So both the conditions are not satisfying, so it goes to else part. So in the else part it prints 1900 is not a leap year. So in the last case I have given 2000. So we are checking 2000 modulo 4 equal to 0. See you know it is satisfying because 2000 last 2 digits are 2 zeros, then it is divisible by 4. So this is satisfying. Then we are checking 2000 modulo 100 not equal to 0. This is not satisfying because 2000 is divisible by 100. So this is not satisfying. So it goes to the elif part. So in the elif part it is checking 2000 modulo 100 equal to 0. Yes, it is satisfying. So one more condition is there, that is year modulo 400 equal to 0. That is 2000 modulo 400 equal to 0 or not. Let's check it. 2000 divided by 400. So cut. Okay, fine. So it is completely divisible. So both the conditions are satisfying here in this 2000. So we can say 2000 is a leap year. So not all century years are leap years. Some of the century years are leap years. So the condition is if the century year is divisible by 100, 400 and 4, then we can say it is a leap year. So let's see the next program. So our next program, write a program to find the given numbers of 1 digit or 2 digit or 3 digit or more than 3 digit. You know the digits from 0 to 9 it is 1 digit. Then if it is from 10 to 99 then we can say it is 2 digit. Then from 100 to 999 it is 3 digit. Okay, let's try. Let's give the command program to check the given number is 1 digit, 2 digit, 3 digit or more. So here we need to input a digit. Digit I am giving equal to int input, enter the number. Okay, if digit greater than or equal to 0 and digit less than or equal to 9, then we can say print digit is 1 digit. Otherwise, if digit greater than or equal to 10 and digit less than or equal to 99, then we can say digit is 2 digit. Again, if digit greater than or equal to 100 and digit less than or equal to 999, then we can say print digit is 3 digit. Otherwise, we can print it is more than 3 digits. Else, print is more than 3 digits. So here, if you are entering a number between 0 and 9, including 0 and 9, then it prints digit is 1 digit. And if it is between 10 and 99, it is 2 digit. If it is between 100 and 999, then it is 3 digit. Otherwise, it is more than 3 digits. So let's see it. Save the program, run it. Enter the number. See, I am giving the number 4. Okay, it is printing. 4 is 1 digit. Let's see with other values. Next one, 26, it is 2 digit. Then I am giving 490, it is 3 digit. Now I am giving 1, 2, 3, 4 is more than 3 digits. So our program is working properly. See here, I have written this program only for positive numbers. So try whether you can do this one with positive and negative numbers. So hope you are clear with the programs we discussed today. If you have any suggestions or doubts, please feel free to comment. So the remaining programs we are going to do in the next video. Thank you for watching.